So today we are going to discuss about circular and rotational motion. So I'm going to start out by explaining to you the simplicity of this circle, right? What happens in this lesson with regard to this circle. So now you have a circle. Every circle has a specific radius, right? For that specific radius, which is measured in meters, always not in centimeters. If it's given in centimeters, you should convert it into meters. For just an example, I would assume that this theta value is 30 degrees. But always remember, if you are determining the circumference of this part of the circle, not the whole thing, but only the part I marked right now, you should consider radian value. What is this radian value? Let's consider about that. So 180 is equals to pi radians. 180 is equals to pi radians. This is a general equation which you are going to use to find the radian value if this angle theta is 30 degrees, right? 30 degrees. So now this is a general equation which you need. So now I'm going to take this 180 degrees to this side and say that it's 180 radians. So now we have 30 degrees. I assume that theta is 30 degrees and I'm going to multiply both sides by 30. So it will be even 30 into 180 into 30, right? 180 into 30. This is 1, this is 6. So 30 degrees is equals to pi by 6 radians. So now if you consider, next thing that you should consider is how are you going to find the circumference of this circle. This is how we are going to find. We denote the circumference of this circle by a simple equation which is S equals R theta. S equals R theta. Always remember that this theta value is not degree value, it's a radian value. Therefore, if you are given 30 degrees and if now that you found this 30 degrees pi by 6 radian, you never substitute this 30 degrees here. You always take this pi by 6 radians here and this is how you do it, right? So R into pi by 6 S equals pi R by 6 meters. Why did I say meters? I said meters because that's the only value existing, right? We have taken this radius value in meters. Therefore, this radius value exists here, so that is meters. These doesn't have any SI units, right? Because they are numerics. So R is the only existing fundamental quantity. So therefore, we consider the circumference of this part, as in meters, right? So now what we got to consider is that the next problem you will have is the angular velocity, the angular acceleration, and all the other types of accelerations we use in this lesson. So now let's find on how to obtain those values. So I'm going to say theta. Theta is given in radians, right? Theta radians. Theta radians. So now basically how are you going to find the normal linear velocity? Linear velocity is determined by the rate of change of displacement by according to time by time, right? So now if we write V equals displacement, which is d over t, both are vector quantities. For this also we have the same thing. This theta value, this radian value represents the displacement of this circle, represents displacement, right? So we can say we denote the angular velocity, angular velocity equals W, right? This W is obtained by the usual thing, the rate of change of angular displacement by time. That's the only change the angular word comes in. So equals theta by t, theta radians. So therefore the SI unit of W is given as theta by t, radians per second, right? The SI unit of W is equals to radians per second. Now what about angular acceleration? Angular acceleration is also the same thing. Basically linear acceleration equals rate of change of velocity over time. So angular acceleration means rate of change of angular velocity by time, right? Angular acceleration. Alpha is how we denote angular acceleration is equals to delta theta over delta t, right? Basically delta w, basically it's w by t. So now you have obtained the first equation and the second equation, right? Rate of change of angular velocity by time. So these are the basic two equations which you got to learn at the first instance. So I'll continue with the rest of the lesson from this part onwards. Now you got to understand that we have three linear motion equations. But also in angular and in rotational motion and circular motion, we also have three equations of the same similar type. Right? This is how I'm going to denote it. So this is the final velocity. Final velocity determine final angular velocity represented by omega. Right? You should always remember this is a Greek letter omega. So omega 1 plus alpha t. This is going to be theta equals omega 1 t plus half alpha t squared. Omega 2 squared is equals to omega 1 squared plus 2 alpha theta. You can clearly see that the displacement is measured in radians, right? We have said always radians. So you should always remember this, theta radians. This one I will take it off because it's not relevant. So in here you can see that this is theta. You can see that time never changes. Time is always t. So you can see that all these terms have changed. Now there is another problem. There are three types of accelerations, right? And there is two types of velocities. What are those two types? We have angular velocity as well as we have the tangential velocity. The tangential velocity is denoted like this. Tangential velocity. So this is linear motion, just forget about this. I'm going to explain something else. So now if I consider a particle moving having a circular motion, right, v meters per second, this is a tangential acceleration because this velocity is a tangent to the circle because it's perpendicular. You can clearly see that it's perpendicular to the center, right? Therefore you call it tangential velocity. This tangential velocity is given by tangential velocity is given by v, right? V is how we denote this tangential velocity. Tangential velocity has the normal usual SI units of meters per second, which is given by v equals r omega. V equals radius times the angular velocity, radius of the circle times the angular velocity, right? You could understand this lesson to the very core when I just continue this lesson in the other parts. This is just the first part. I'm going to explain the basics of this lesson, right? This is the very basics of this lesson. So I hope you pay full attention to today's lesson. So V equals r omega is the tangential velocity, as velocity is the angular velocity, and this omega equals angular velocity, radius equals in meters, right? Tangential velocity. So I hope you draw a box around it because this is a very important equation. Next we have tangential acceleration. What is this tangential acceleration? This we obtain like this. Tangential acceleration is obtained, tangential acceleration is usually given in meters per square second, right? A ms minus 2, right? You know this, right? So this is given like r alpha, radius times the value of the alpha value. So now we have obtained 4 equations, total of 7 equations for today's lesson. So this is actually going to be a 15-minute video, so I'll just time it to the correct amount. So now we have this tangential acceleration, tangential velocity. What are the other things? Now if you consider this circle, practically if you think when you are, I'm just going to apply it in real life, right? So when you're traveling in a bus and when you take a turn, you have motion to the side of the bus. Like if the bus is turning this way and if this is a person, he will be like this, right? He will bend away from he will move away from the circle. This moving away from the circle means that there is a centrifugal force acting towards him, right? And there is something called centripetal acceleration, centripetal force, and centrifugal force. So centripetal acceleration means that when this particle moves in a circular motion, that it has a specific type of acceleration called the centripetal acceleration, which makes it in contact with this circular motion. For example, if this motion moves away because of centrifugal force, this this won't have a constant motion, right? That motion and the radius will change from time to time. Therefore, there is centripetal force, and for the centripetal force, there is something called the centripetal acceleration. Centripetal acceleration is given by 3 different equations. What? 3 different equations. So centripetal acceleration is given by like something like this. So I'm going to say centripetal acceleration. Going to denote it like AC, right? It will have V squared over R. Equation A. This V squared over R we can write like this also. V equals R omega. V equals omega. V equals omega. Tangential velocity times the angular velocity. And we can say R omega square. B C. So now you can clearly see that it has 3 types of equations: centripetal acceleration, tangential velocity squared over radius, tangential velocity times the angular velocity, the radius into the angular velocity squared. So this is basically, this has the SI units of meters per square second, just like we had it in here. So I hope you this video was quite understandable and quite accurate for you and for your education. And if this video was helpful, make sure you subscribe, and it will be a huge support to this channel. And I hope you share this video with your friends if anyone, if they need it. So this is about the first things which we should discuss in this lesson, which I discussed in brief. I discussed this in 14 minutes, right? I discussed this in 14 minutes. So I hope you have a nice day, study well, and have a good time.